All right, welcome everybody. Welcome back to day 3 now of our PrepAdviser Veritas Prep course. I want to extend a special welcome to my friends Chris and Bridget. They are Veritas Prep instructors, kind of learning how the film studio setup works. So apologize for keeping you guys waiting. We had one of the things we were half a second late or so. It was because the camera here was doing double duty, taking care of the recording, which will be live to your PrepAdviser accounts here pretty soon, and just takes a couple hours to get the recording all downloaded and everything. We had another class after this yesterday. So anyway, excited to be back. Today, if you guys enjoyed Monday, and I know I did, we did some data sufficiency. We're going to dive pretty deep on data sufficiency strategy. Just to remind everybody where we are in this whole process for our mini course here. I guess before I say too much, let me just say welcome back. Let me know if you're out there, if you've been, for how many people is this day 3 that you've been with us and you're excited to be back? And John's, I think, posting some of the notes about logging out back in. Awesome. Thanks, Marissa. I'm glad. Me too. Awesome. Tariq's back. Tariq, you had a couple comments that made their way around the office yesterday, celebrity sightings and everything. So thanks everybody for the enthusiasm. Glad everybody's back. Anybody just joining us, there will be recordings posted to your PrepAdviser accounts here pretty soon. So you guys will be able to check all that out. So thanks everybody. We're excited to be back. Another beautiful day here in Southern California. Hopefully it's nice where you are. Here's kind of where we've been and where we're going. We did that intro on Monday. We did critical reasoning yesterday, and it was interesting. I had to teach a GRE class. Got to yesterday afternoon, and it was also critical reasoning. So I kept referring to things that you and I had talked about that they hadn't heard yet. So you guys left an impression. But that group at the University of Missouri is keenly aware of PrepAdviser now too. Today we're going to do data sufficiency. I think this will be a lot of fun. All the statistics are back, so we can take a look at trap answers and all that kind of thing. Tomorrow we won't be meeting in this room, but I'll still be with you. You're going to do the pre-recorded sentence correction lesson, which is called On Demand. That'll all be available for you. And actually, this is blue already, so let me change the arrow color. Through this link here, which a lot of you followed even to get here. So if you go back to PrepAdviser, you'll find a link to that. Friday's kind of an exciting day. You'll get a chance to take some practice tests. We have a whole set of practice tests available for you. Again, you'll access those through the PrepAdviser link. And those are something we're really excited about. A couple of the new tech developments here at Veritas Prep. One is this classroom where we can kind of come live in streaming video and I can move my arms and you guys can see it. The other are our practice tests, which are fully computer adaptive using item response theory, which is the same system that scores and administers the GMAT and other computer adaptive tests. So you guys should get a lot of value out of those. And then we'll be back together a week from today for overall Q&A. You can follow up on sentence correction, which you'll see tomorrow. You can follow up on any of these lessons and a lot of the homework and things you've done. So a lot still to go. We're excited about all of it. One other thing I may not have done an amazing job of highlighting the last couple days is this forum here. One of the kind of the beautiful things about, I guess, crowdsourcing and just sort of the new tech generation, you can say something once and everybody can read it. So we're going to direct a lot of your questions as you're going through homework or just kind of general questions about the GMAT or anything like that. If you go to the PrepAdviser forum, they have some experts. I'm one of them. I shouldn't call myself an expert. They have some experts plus me who can answer questions there. And then the beautiful thing, if you asked a question, I'm sure other people are thinking about it, and those will stay there permanently so that everybody can get some access to it. Cool. So this is sort of a rundown of where we are and where we're going. Let me take a quick step to the side. The last comment every once in a while gets a little bit cut off. Jimmy was asking, test on Friday at the same time. I would suggest doing it that way. It won't be a live event that we're all doing together. You can kind of take it on your own time. But I would, if you've been dedicating this time every day, it's probably a really good idea. So hopefully that works. So Garash is how to have the Q&A. If you have what was I gonna say? If you have an emergency and need to leave, we're recording it. For for the recap, anything that you need to know about when anything's taking place, where to access things, go through PrepAdviser. So if you're asking like where do you get the Q&A session, all those will all be available through the PrepAdviser site. So again, quick step to the side. School, awesome. So hopefully that all works. I think we're on the same page. You guys ready to dive in for some more data sufficiency? People typing. We'll do a little more housekeeping all the way at the end. So we'll get there. Nice. Glad the connection's working. Streaming's good. Here's where I'm not a huge fan of I was going to say animation. So we'll just get it all up at once. We've seen these and we've worked on a lot of this stuff already, but just to kind of review, make sure we're all on the same page. We did some more think like the test maker stuff the other day. The way data sufficiency works, there's always the question stem, there are two statements, and then there are the answer choices. So you guys should be pretty familiar with what all these look like by now. One of the reasons I want to call this out now is just to remind anybody that's joining us for the first time, the answer choices are always the same. And so by the time you take the test, you shouldn't have to read them. Actually, on a few of the questions we'll go through today, we'll just leave the answer choices off. We'll just kind of show them to you, but we'll get rid of them off the slide so we have more of a chance to totally work. So make sure you know these by the time you get to the test. There are all kinds of mnemonic devices and things. Generally speaking, if you've done 30, 40 of these problems, you should have these ready to go and not have to think about the answer choices too much. And then you can really focus on the questions. Now, from the answer choices, here's how I want this to kind of guide the way that we think about data sufficiency. Take a quick read of answer choice C and specifically what it says, because this to me gives you a lot of insight into what is data sufficiency all about. And if you haven't finished with those links, I'll leave that slide up at the end, so you'll be able to get a snapshot of it all. So sorry about that. Here's what's interesting to me about C. It's only one of the 5 answer choices, but what I like about bringing this one out specifically, both together are sufficient, and it's that word but that's so important in sentence correction and in reading comprehension and other things. If you can note transitions, that's generally important, but neither alone is sufficient. Essentially, if you think about what makes this a good question type for a business school test, it's really testing how well do you use resources. If I can do the job with just statement 1, and you can do the job, but you need 2 statements together, in business I win because I can do it more efficiently. I can pass the savings on to the consumer or onto the shareholders. I can do a better job if I need fewer resources to accomplish the same amount. All right? So if you're looking at what is data sufficiency really about, it's about resource management. It's if you could do it with 2, but somebody else can do it with 1, then you probably want to pick for 1, right? So this is where we talked a lot the other day about leveraging assets and playing devil's advocate. The flip side to it is if I bid for a contract and say, oh yeah, I can do it for less than $1 million, and then there are overruns and it turns out, hey, I misestimated that and it's going to be a lot more, then somehow I'm paying for it. I might do it at a loss. So there's a flip side to it. It's not always pick D because that's more efficient. You have to be kind of critical thinking with it. But that's really why they're testing this, is how resourceful are you with information, and can you play devil's advocate? If it seems like everybody's saying, oh, it's totally totally doable with just 1 statement, kind of look at it and like, is that really the case? Or if I think critically, do I really need to, or can I do it at all? But it's really a resource management question type. And so if you think about it that way, it's not just a math question with weird answer choices and structure. It's testing a lot of those business skills that you'll want to have to be successful in B school and beyond. Cool. So that's kind of how we want to guide our thought process. And this is a little bit of review for those who were with us the other day. Again, that resource management idea, the only way you're going to get a question wrong is if you think you have enough, but you don't, so you're wrong. Or if you think you don't have enough information, but you do. Again, that transition with the word but, that's when you're wrong. And remember, this is a little bit of review so that we're ready to go for the rest of it. the ways that they tend to get you to make this first mistake, where you think you have more information than you really do, or you think you have enough, but it turns out that you don't. Most common way they'll do it is to have you make an assumption where somewhere in your mind you think, I'm only thinking about positive numbers, you haven't considered negatives, or I'm only thinking about integers, but what if it's 3.5 or 0.1 or something like that? So this is the idea of play devil's advocate, is think about all the situations that might change the game just a little bit. All right? So what about a negative number? What about a number near infinity? What about the smallest possible number they'll let me use, the biggest possible number they'll let me use, strange numbers, a negative fraction or something like that? Try to break it a little bit. The other one is they'll get you to use at least some of statement one, or if not all of it, before you're allowed to. And that's why you want to keep these separate, although we'll talk about why having blinders on is a bad idea too. So we're going to reassess a lot of this. And then remember, a lot of times, probably more often than the other way, this is the one that's the difference. You know, if it's 50-50 on the whole test, it's probably 60-40 above the 700 level. Usually they reward you for leveraging assets a little bit more, for being able to creatively say, I bet that fact that it's the number of children will be important. We're going to see a handful as opposed to something that's maybe a non-integer. We're going to make sure we spend a good amount of time a little bit later on today specifically on leverage assets. A lot of times, what I'll tell people, have you guys heard the phrase, I feel bad, people are coming in saying hello and I'm just talking. So, hey Rosie, how you doing? You guys have the phrase, maybe it's universal, dress for the job you want, not the job you have? I don't know if that's as universal as I say, show up in a suit if you want to be a manager. Don't show up in jeans or whatever that. It's an American saying, basically like act like you're the person who has that kind of a job, right? So some people know that one. I would always say pick the data sufficiency answer choice that the person going to your dream school would pick, not necessarily the one you would pick, right? So I always say and if we get to we'll come back to, I think I have another slide in here that'll do that. Don't pick E because I can't do it. Pick E because Stephen Hawking can't do it. So if you're looking at a problem, this is kind of the leverage assets thing too. If you're ever looking at a problem and you're like, geez, I can't do it, be like, you know what? There's a lot of information here, and I bet someone a little bit smarter than me, someone who goes to the business school that I want to go to, I bet they could figure out a way to do it. Then that's not a bad place to start to guess a little bit. So, and either force yourself to leverage assets or at least kind of say, hey, it's too obvious that it's E. Doesn't look like you could ever do this. There's got to be a way to do it. So we're going to see actual examples of all this and learn a little bit of strategy. But the general idea here is it's about resource management, it's about critical thinking, and we're going to break down some strategies to make sure that we're thinking pretty specifically about how to attack data sufficiency and not just math questions that are a little bit different from what we've seen before. Cool. So yeah, I tend to start a little abstract, and you guys know me by now, and then we'll get a little bit more concrete. There's really two phases to what we're going to do in this lesson. One is we're going to look at what's your data sufficiency toolkit. I think I do have that up there. So what tools do you have in your toolkit? When you see a data sufficiency problem, what should you do? And if we go back to that pyramid structure that we've had on a lot of these, where it's basically skills, strategies, and then think like the test maker. First portion, we're going to focus on strategies. What do you do when you see a data sufficiency problem? And then after that, we're going to start to think about the gamesmanship of it. What are they really testing, and how can you kind of see symptoms of, oh, I bet they're going to reward me for spending a little more time on statement 2 or for considering negative numbers or something like that. Cool. So this is kind of where we're going. Phase 1 will be really strategy and what do you do on these problems. And then phase 2, about 45 minutes, half an hour or so from now, we'll kind of hit that top of the pyramid. Here are kind of the dominant themes of what should you be doing more often than other things when you're looking at data sufficiency problems. First one is algebra is heavily rewarded on this test overall. And so if you feel a little bit weak in your algebra skills, if you kind of get a little bit upset every time that there's two variables or variables and exponents or anything like that, there's really not much substitute for just good algebra skills. A lot of problems, for whatever reason, the GMAT's a heavier algebra test than most people realize. So we want to put this first. When in doubt, try to do some algebra. People a lot of times like to pick numbers, like to make things concrete, a good strategy, but if you can do algebra well, then you'll be able to do things a little bit faster than other people or see patterns a little bit faster. Another one is to use conceptual understanding. Some things you just kind of have to know the math concept of, oh, 2 is an even number, but it's also a prime number. Or if you square a positive fraction, then it actually gets smaller, or a number between 0 and 1. Certain times you just have to rely on a concept to be able to say, oh, I get it, this kind of number will react this way, that kind of number will react that way. So have that, and that's usually quick if you can kind of see, oh, I bet they're testing even property versus odd property, fraction versus integer, or something like that. This third one, I should say, is people generally do a lot of picking numbers, which is not a bad strategy at all. What's interesting, though, is that people tend to pick numbers poorly. And so this is where we're really going to bring in the idea of play devil's advocate. We're going to see examples of all these. And then this last one, we can talk strategy all day. Sometimes it is still a test that heavily involves math. Sometimes you just have to do the math. So we're going to go through an example of each of these. Make sure you know which skill sets to bring with you on test day. When you see it's a data sufficiency problem, these are the things you should be thinking about. We kind of say to think about them in this order as to where your your return on investment will be, and then we'll get to work on all that. So let's start with this, and we'll give everybody a quick opportunity to see what one of these, actually I should kind of preface, we're only going to do one statement at a time. So your goal here is it sufficient or not, as we're looking at all of these. Talk to me about this setup here. So we've got 3 variables for integers a, b, and c. This whole quantity is equal to 1. What is b minus c over b? What are your thoughts on how can we start to work on statement 1? And for time, it's all that information about all the other resources and activities are all available at PrepAdviser at those links. So if you follow, go back to that site and they'll have all the information. So they don't turn on until Friday. So once you log into your account on Friday, it'll be there. But to this question, what would you guys do here? All right. I like what Jimmy's saying, right? Is A equals 3/5 B. So we can also, now they gave us this asset, we also know we can multiply both sides by B and say that A equals 3/5 times B. Now we have a couple data points, a couple pieces of information, right? So we can take that and start to work through something. I actually really like what Des says here too, that here they gave us this fact. And with this is the one I want to lean on just to show you people underestimate the value of the information in the question stem. If you realize that A equals B times C, just off of, I'm sorry, B minus C. So if we just multiply both sides by the denominator, A equals B minus C, well then if B minus C is the same thing as A, look what question they're really asking us. They're asking us, what is A over B? Well then they tell us it's 3/5. So if you get comfortable, anytime there's algebra, especially with a couple of variables, if your goal is, hey, I'm going to just work on all the algebra. Every time they give me a statement, they told me A over B minus C equals 1. I know that A equals B minus C. I also know that A plus C equals B. Every time they give you one equation, they give you a couple others if you're willing to manipulate it. And so on a problem like this, a lot of people go to statement 1 and they start testing ratios. Okay, what if it's 3 and 5? What if it's -6 and -10? What if it's 30 and 50 or 15 and 25? And they keep plugging in numbers over and over again. If you know to manipulate the algebra, This one here is kind of inconvenient. If you take the next step, go to here, well then, wherever they say B minus C, that's the same thing as A. And so the question actually just asks you, hey, what is this? And then they just give it to you. All right. And actually, I love the commentary going on here. Did you go too far? The beautiful thing about algebra is you can't break it. Right? So if you realize you went too far, if you do a couple manipulation steps and go, oh, wait a second, actually, I think that went a little too far for me, or hey, this actually made it messier, you can always go back. But one thing you tend to want to look for is, can I make the algebra in the given information in the question stem look like the algebra in the statement? So there's really two ways to go, which is make the statement look like the question, or make the question look like the statement. And so those are your goals as you attack some of these. Hey, they gave me some algebra here that was a little bit ugly. Can I make this look a little more like this? Can I make this look a little more like this? And so that manipulation, and actually I've done this one. I'd be a little bit embarrassed to tell you. Good question about what kind of level of question. I'll be honest with you guys, the first time I saw this one was probably 10 years ago. I was going to teach it in a class on a Saturday morning, and my first thought, there are notes in my first book that I tested a bunch of numbers, and it took me 2 or 3 minutes. I got it right, but it was probably, you know, around average level or a little bit more. But the good thing is, if you know to manipulate the algebra, it's dead easy. So this is one where maybe people get it wrong, but also a lot of people spend 2 or 3 minutes on something like this, and then now they get something else wrong as a result of it. So I'd probably say maybe average, maybe even a little bit more than average, because remember there's a statement 2 on it also. We'll get to how those can work for you or against you. So I'm not going to claim this is the hardest thing in the world, but I've seen people spend 2, 3, 4 minutes on a problem that's not all that hard. Right? No, actually, because I'm just guessing. So if when we have the statistics up, if I have real stats, I'll show you actual stats. I don't want to tell you like, oh, this is definitely a 700 problem, and it turns out it's not. Like, if I have good information, I'll tell you. If I'm just guessing, I don't want to misrepresent the test at all. So when we get to the actual questions, they'll have real statistics, and then you can see for yourself, oh, this % of people go for the trap or whatever. Otherwise, I hate trying to like give my own opinion on it, because what's hard for me might be easy for others or something like that. So the big thing is, know that algebra is a huge factor in this test. People love to pick numbers right away. You can be a lot more efficient if you're using algebra. So make your first instinct when you see multiple variables and things to try to do a little bit of algebraic manipulation. This one here gave us a couple statements. This one here gave us a couple statements. You can turn one kind of inconvenient fact into the smoking gun to solve the whole thing if you need to. One other big thing is that you do need a lot of conceptual understanding. I kind of find this interesting for this test, that if you know what they're testing right away, on data sufficiency you can be really quick. That's kind of one of the other goals on that previous question is, yeah, maybe most people would get it right given 3 or 4 minutes, but there are a lot of questions that are going to take you over 2 minutes. You have on average about 2 minutes. Then if you get that done in 45 seconds, now you have a whole lot of time. Right? And so that's where you want to be as efficient as possible. Let's take a look at this one. They're asking, is integer k prime? And then they give us this. K equals 10 factorial plus m, where m is between 1 and 8. What do you guys think they're testing here? What kind of concepts are you looking to employ? Nice. Divisibility, prime numbers. I see what Tariq's doing, kind of moving all those numbers across. All right. What is 10 factorial? So this is one where if you know what the factorial is, you've got a pretty good leg up. They do test this, so if you don't, make sure that, so 10 factorial is 10 times 9 times 8 times 7 times 6 times 5, 4, 3 times 2 times 1. So that's what 10 factorial is. All right. Perfect. It's number properties, number theory, factors and multiples. If we add any of these numbers, so they define here, and this again, make sure you leverage assets. They told us k has to be an integer. All right. So we know that since k is an integer, and it's this big number, 10 factorial plus m has to be an integer. If m is a quarter, then this number is something 0.25. So we know also that this means m is an integer, because that's the only way that this definition will be satisfied. And then if you recognize, so I can either add plus 2, plus 3, 4, plus 5, plus 6, or plus 7. Whatever we add, this number 10 factorial is a multiple of 2. If we add 2, it stays even, and so that wouldn't be prime. This number is already a multiple of 3, so if it turns out that m is 3, if we add a multiple of 3 to it, it's also not prime. And the same thing is going to go all the way down the list. Since this number is a multiple of 7, if you add 7 to it, it stays a multiple of 7. This is one of those conceptual things where this number's too big to visualize or to actually put some math in. So you do have to have some pretty good conceptual understanding. Do enough practice. The homework for today will be some pretty good practice to kind of let you know, which concepts get tested a little more or less than you might think. Factors and multiples, they test a lot. So if it looks like I'm speaking, I hate to say like speaking Greek or another language, because some people do speak Greek or whatever. If it seems like it's speaking a total foreign language to you right now, these are concepts. Factors and multiples are kind of a big thing. The other thing I should point out on this one is every one of these, they asked a yes/no question. Every one of these gives us the answer no. All right? It's not prime. It either is a multiple of 2, it's a multiple of 3, it's a multiple of 4, 5, 6, or 7. It's not prime. Here they give us the answer no. One kind of no great lesson on data sufficiency would be complete without saying sometimes the answer to this question is definitively no. But what we're trying to figure out is this statement sufficient? And if we get the guaranteed answer no, then it is sufficient. So this statement's sufficient. No means sufficient if it's definitively no. And so keep that one in mind. For whatever reason, we cross wires in our minds where if we see no, we want to cross out that answer choice. Statement 1, no, the answer is no, but it actually means that it's sufficient. So be careful there. This is one, too, where one of these concepts, you really can't prove that it is prime because it's too big of a number. The only thing you could prove is that it's not prime. So if you get some of these concepts, you kind of have a pretty good leg up on how to attack it. Well, so the big takeaway here is a lot of data sufficiency rewards good conceptual understanding. And so if you know some of these concepts that they like to test, factors and multiples is a big one, prime, not prime, how do fractions react differently from negative numbers, from 0, from positive numbers, those kinds of things. If you're comfortable with those, a lot of times you can make a pretty quick determination on these just by knowing the concept. Cool. So let me pause here. Questions, comments on any of that? Probably don't have enough time together to really justify a real deep dive on the factors multiple stuff, but general ideas, some of these, you have to have pretty good deep understanding of the concepts. Good question. They add a degree of difficulty that a lot of people aren't ready for. I look at it this way, and actually, is anybody here from France? I think we had a couple, right? So I'm going to use a Tour de France analogy. Okay, perfect. So Franco's with us. We got some others who are French. You may boo me for this one, but one of my heroes still is Lance Armstrong. he just wins, even if he has to cheat to do it. If you can find an edge. And one of his my favorite quotes he has is, "When I wake up on race day and it's raining, I'm thrilled. Not because I like riding in the rain. I hate riding in the rain, but I hate it less than everyone else." And so to Anna's question about is data sufficiency the trickiest part? Maybe it is for a lot of people, but it can also be your competitive advantage, right? Lance loves riding in the rain because everybody else hates it more than he does, and so he sees it as a competitive advantage. Like, I'm not going to like it, but everybody else is going to suffer more. Same thing for you. If you get what data sufficiency is about, that, oh, if I get the concept, I don't really have to plug in a ton of numbers, or, hey, if I realize that answer choice C is a little bit too easy, that means I need to lean on one of these statements and work a little bit harder. If you get what it's about, it's still tricky, but it's your competitive advantage. It what helps you to score higher than everybody else. So I look at it as, it's like, if you're the best golfer in the world, you want to play 18 holes and not one. I can get lucky and beat Tiger Woods on one hole, maybe. I can't beat him for 18. You want this to be a competitive advantage because everybody else struggles while you at least struggle a little bit less. Cool. It's, I like the tricks with me on competitive advantage. This is sufficient. Now, we don't have enough information to answer the question. I can't tell you if it's A or D, but we're just doing one statement at a time to kind of show you what the toolkit is, what kinds of things you need to know. And this one is sufficient. Even though the answer is no, it guarantees exactly one answer. So this one's sufficient, which means the answer would be either A or D. And there's another. This one actually may end up in your homework, so I won't give away what the other statement is, but you'll see it when it comes up. Cool. Now, I'd say the most important demonstration out of all this is this one here. Why don't we do this? I'm going to just hang back. This one you may want to go full screen. I probably should have moved this over a little bit so that I'm not standing right in front of it. If you guys want to go full screen on it, or if you can see this here, take a second and maybe 15 seconds. I'll step off the screen real quick. Let me know, do you think this is sufficient or not to answer this question? And we'll talk about this one. You kind of have to pick numbers on, but this demonstration I think is important. So I'm going to step off and give everybody a chance to look at it, and we'll turn this into a conversation in a second. All right, great comments so far. Looks like we're leaning toward no. Prita, let me, if I can add, just kind of follow up on your statement. Each statement is sufficient. We go back to the answer choice. It's statement 1 is sufficient or it's not. Statement 2 alone is sufficient or it's not. So we can't answer the entire question right now, but we can determine whether one statement is sufficient or not at a time. So it's almost like we just haven't looked at statement 2 yet. All right. So they want to know, is this product equal to 1? How did you guys get there? A lot of people saying not sufficient. How do you know? What tells you that it's not sufficient? All right, so it looks like picked a few numbers. All right. 2's to 2's, RA, perfect, it's a maybe. We could get there. All right. So here's where, if I were going to start this one, you guys are showing some of the numbers in here. Corey, I love the way you're manipulating the algebra a little bit too. All right. So, and Des, you're hitting the follow-up question I want to ask right away. So let me kind of show you the way I would think about this one. We got a big group, so if I missed your comment, please forgive me. It's not that hard to come up with something that that gives you the answer no. If we want to come up with no, or actually let me not even skip this. If we just want to pick some numbers where JK over MN equals 1, it's pretty easy to say, how about 8 times 1 over 4 times 2? Well, that works. We can pick numbers. If J is 8, K is 1, M is 4, and N is 2. That works. So then we go, okay, what is 8 times 4 times 2 times 1? We don't even need to do this multiplication to say that it's 64 to go, okay, this is definitely a no. All right. Now here's where, if you're picking numbers, I think it's absolutely crucial you do so to play devil's advocate. Because sometimes what people will do here then is say, okay, let me pick another set of numbers. And the numbers they may pick might be, say, how about 6 and 1 and 3 and 2, and then they'll do this and say, okay, well, that's going to end up giving you 36, so that's a no. And then they may try something else, 16 and 1 and 8 and 2. What's wrong with what I'm doing here? I'm picking numbers. And it may be a lot to articulate, but type it in if you kind of see what's the flaw in my process here. Yeah, Tariq, perfect. They're the same kinds of numbers, right? They all give the same answer. This is what I mean by play devil's advocate. If you're picking numbers and you already have a no, the only thing that helps you is getting the answer yes. You want to try to prove that it's not sufficient. And so what you want to do is try to push the limits of, hey, what kinds of numbers am I allowed to use? And so did anyone consider, well, what about 1 times 1 over 1 times 1? Well, that would mean that it's 1 times 1 times 1 times 1. So that gives me a yes. As soon as I have a yes and a no, then I know it's not sufficient because I can get 2 different answers. All right. So I might use this, 1, 1, 1, and 1, get a yes and be okay there. Or, and a couple other people have mentioned integers. What if I said, how about 4 times a fourth over 2 times a half? Well, that fits. It all equals 1. But then when I multiply it all out, 4 times a fourth times 2 times a half, then the 4's cancel, the 2's cancel, and it's 1. So there's another yes. And so I can say, yeah, okay, it doesn't work. I have 2 different answers. So let me pause. Everybody see, your goal here when you're picking numbers is you want to try to get different answers. And you want to play devil's advocate. Okay, it's obvious I can get a no. How do I get a yes? All right. A follow-up question for you. Does anyone look at this one and go, really, all ones? Isn't that cheating? So let me know if you look at this and say, I don't know if that's legal. Because I personally would be a little squeamish about that one. Like, really, can you just do that? Can you really just say they're all 1? It seems kind of strange. And people actually don't like this a lot of times because they're like, well, but they're different letters. Why would they be the same number? If they don't define it as unique integers or unique values of j, k, m, and n, then you're allowed to use it. Your job is, I want to use every possible option available to me so that I can try, right? So hopefully, Corey, if you're getting these right, don't let me pollute your mind a little bit. People don't like this one. I'm like, but they didn't tell you you're not allowed to. Same thing here. Hey, am I allowed to use fractions? If they didn't say, and this is to Jimmy's point, if they didn't say they're integers, then you have a responsibility to try fractions. And so often, and this is where I'll grandstand on this one for a little bit, so often people get questions wrong and they go, man, I can't believe they tricked me with a negative again. Ouch, they always get me with fractions. Or, wow, I can't believe you were allowed to use, a number close to infinity, and they get mad. I don't know if you guys have been there before on some of these where you think like, oh, they tricked me with a negative. They tricked me with a fraction. I tend to look at it a little bit differently. I'm going on offense. Those are weapons for me. Okay, I see you made it easy to get a no. Here's how I'm going to get a yes. I'm going to try every number I can think of. I'm going to try negatives. I'm going to try fractions. I'm going to try all the same. I want to push the rules of a game. And I think if you think of it that way, you're on offense. You're not defensive when you do these. If you're picking numbers, you're attacking. You're saying, okay, you made it easy for me to get a no. How how in the world am I going to get a yes? I'm going to use every type of number I can think of. And if after 45 seconds or so, you're like, hey, I've tried everything I can think of. I tried the biggest number they let me use, smallest. I tried them all the same. Everything they didn't define, I wasn't allowed to do, I tried, and I always get no. Then you can assume that it's sufficient. Too often people just pick the same type of number over and over again and go, well, third time's a pattern, it must be true. Here, when you're picking numbers, you want to be on offense and attacking. I need to try to get the other answer any way I can. And if you can't, after you've really racked your brain, then you can probably assume that it's sufficient. Cool. So let me pause here. I think this is a really major point that we just see people screw up a lot. Everybody on board with that? When you pick numbers, do it with a purpose. You're playing devil's advocate. You're trying to get two different answers. And then the last one, don't tell Nike we might get sued. Sometimes you just have to do the math. We can talk strategy all day. Sometimes you just have to do the math. I'll pause that. I think hopefully this helps, Corey. If you realize that when I'm picking numbers, I'm doing so with a purpose. Because that's the other thing. Picking numbers is kind of time consuming at times, where you're just sort of like picking, like, okay, if I plug this in, what do I get? People don't really know what they're doing. You have a goal in mind. When you're picking numbers, you're trying to get different answers. And I think that kind of helps. Like, at least you know what your mission is. And I think that, to me, makes it feel a whole lot more productive. Cool. So, nice, cool. We're getting on the same page. We're making some progress. With this one, hey, we could think all day. Conceptual understanding, oh, it's a quadratic. There's probably two answers, on and on and on. Sometimes you just have to do the math. How would you guys factor this one? Nice, Glog. Jumping ahead, what we want to do factoring this one is say, okay, they have to multiply to this number and then add to this number. And so if you have x minus 1 and x minus 6, they multiply to positive 6, they add to negative 7, which means, and this is one step just while we're doing this, you actually need to set each of these to 0. A lot of times people say negative 1 and negative 6. Here we get 1, or we get 6. 6 gives us yes, 1 gives us no, and so we can prove that this is not sufficient. All right. So this is how you want to attack. Sometimes, I won't say this is how you attack. Sometimes you just have to do the math. So there's good strategy, there's number picking, there's concepts, there's, this one could be kind of considered algebra too. Sometimes you just have to do the math. Solve for x and see what you get. So don't let me let that point slip. I think sometimes people think so strategically that they forget, like, oh, I could just do the math and figure it out. Cool. So let me jump over here. Do we have to keep, so Grash this question, both alternatives? So what we mean is on the previous question, if we got the answer yes and we got the answer no, we know that this statement is not sufficient to give us exactly one answer. Right? So if we can get two different answers to this question, we know we don't have sufficient information. So we only have sufficient information, enough information, if we guarantee the answer is always the same to this question. Like on this one, well, we can solve for x. It's either 1, which would be no, it's not greater than 4, or it's 6, which would be yes, it is greater than 4. So since we get two different answers, we don't have enough information. We're saying, hey, we can't answer it. So we got close, but we can't answer it. Cool. So, and that's that difference, sufficient and not sufficient. Sufficient means guarantees exactly one answer. Not sufficient means that we don't know. It could be multiple answers. Exactly, yeah. If there's only one answer, if this had asked instead, let me give you the hypothetical, is x less than 10, say? It's 1, it's 6, so it's always yes. Then it would be yes here, yes here. Even though we don't know what x is, we do know that the answer is always yes. So you can look at it that way too. So if you can get the same answer every time, then it is sufficient. Cool. Sorry, off-screen shout-outs. We're doing a little housekeeping stuff. Cool. So that's the toolkit. What I want to do after this is attack a whole bunch of actual full problems. People are asking for difficulty levels and all. We're going to get a little more strategic. I did want to make sure we at least got some building blocks on, hey, what types of skills are you using on a test like this? Use a lot of algebra. You should also have pretty deep conceptual knowledge about things like factors, multiples, prime numbers, how positive reacts from negative and all that. When you pick numbers, and I think hopefully that's the biggest takeaway for you guys from this set, do it with a purpose. And sometimes you just have to do some math. Right? And then Tariq's proposing, if we add here that is x, which is a multiple of 3. Yeah, if they add another condition, you better use that and see if that knocks off one of these answers. So yeah, definitely. Cool. So that's the toolkit. What I want to spend the rest of our time on, this is perfect on pace. I have a bunch of questions here that I want to make sure we get to. There are a lot of ways to look at data sufficiency answer choices. By the time you're ready to take the test, like I said, you'll know exactly what they are. If this is relatively new to you, you may even want to just, if you have a book or resource with all the answer choices in front of you, keep it nearby. Here's really what these, if you kind of look at the levels of answers, this eye chart here is a helpful way. I don't know if you need to have this written on your noteboard on test day or anything like that. I probably would advise against that. But just think about what do these answer choices mean when we're talking about resource management. Answer choice D is that each statement alone is sufficient. This is sort of the top level. This is, hey, it can be solved either way. I can do it with statement 1, I can do it with statement 2, either one works. And if we're thinking about resource management, that's like you going to, the director of human resources and saying, hey, give me him, give me her, I don't really care who you give me, just give me one team member and I'll get this project done. The second level down, A and B are essentially the same amount of information. It's, hey, I can do it with one statement, but I have to pick which one. I can do it with statement 1, but I can't do it with statement 2, or I can do it with 2, can't do it with 1. C is, hey, we can get the job done, we're going to need both resources. In a way, you're kind of paying for both resources. That but both together are neither alone means hey, it's going to cost us something to do. It's going to cost us 2 statements, not just cost us 1 statement, but we will get the job done. E means job can't be done. All right. Now, this is one way of just kind of looking at these levels, which means if they make it seem pretty obvious that the answer is C, you want to double check. Am I sure that I can really do it? Because maybe if I play devil's advocate, to go down, you want to play devil's advocate? Like, am I sure that I can do that? Or is there some strange situation? What if they were both negative fractions? What if this was a crazy obtuse triangle that looked like this, where there's really no value to if this is a huge angle, these are really small. How can I work with this to get a crazy situation where it isn't C, where actually you can't really solve it? Or, hey, wait a second, is one of these statements sufficient on its own? And that's leveraging assets, which is, if I think it's C, I better check this level and this level. If I think it's B, wait a second, is the other one sufficient and maybe it's D? Can I actually do it with statement 1? Or does statement 2 really give me the information I think? So you kind of want to, anytime you're about to pick an answer, go up a level and down a level and just ask yourself, hey, it seems like they want me to pick A here. So I better check, do I really need the other one or not? Could it be C? Or, hey, is the other one actually sufficient and it's D? Before you pick E, make sure. Prove E. E a lot of times people like because it's like, hey, I can't solve it. Seems like a hard problem. You have to prove that one. E doesn't mean I can't do it. E means Stephen Hawking can't do it. Steve Jobs can't do it. Really, no one named Steve could ever do it. And so you're really you're pushing it. But if E looks obvious, better make sure it's not C. If D looks obvious, there may be a flaw in one of those statements. You better go down and double check that. If C looks obvious, check 1, check down. What we've seen to date with that first lesson we did is they like to funnel you toward one particular answer choice. It's up to you if in 30 to 40 seconds it seems obvious that it's one thing to think critically, let me just make sure it's not something else. And so what we want to do, again, this is pretty abstract right now. We'll come back to it all the way at the end. I want to just go through some problems that have statistics on them, open the poll, let you guys get a crack at them, and we'll look at what they're doing to funnel you one way and how we can think critically, playing devil's advocates, leveraging assets to use those clues. It seems a little bit obvious. Where am I going to go on this? So there's really 3 things I want to go through. We foreshadow play devil's advocate and leverage assets, and then this is somewhat new, kind of I don't want to say advanced level, but it's I want to add this dimension to it all too, and we'll hopefully make you guys, again, that competitive advantage. It's like riding a bike in the rain. You guys are going to like it at least more than everybody else, even if you don't like it. Cool. So I want you guys to look at this question for just a second. This one, the diagram is about as big as I can make it. So if you want to go full screen just to get everything, go full screen. I'm going to give you guys a minute. I'm going to clear out that poll and give you guys a minute to look at it. Just kind of get comfortable. If you want to do some math, want to use conceptual understanding, whatever, I'm going to hang back for a second, let you guys look at it, and then I really want to discuss, hey, what do we know about this problem just by looking at it right away? So take a look. I'm going to clear out the poll if you want to log your answers there, and then we'll get a chance to discuss in just a second. All right, so let's talk about this. I'm in as a junior member of the session today, so I don't have the permissions to do all that. Talk to me about not even the answer necessarily. What do they want you to pick here? What do you guys see almost like right away obvious? What do they want you to pick? I'm with Rosie. They desperately want you to pick C, right? Whoever wrote it is saying, and they want you so badly to pick C here. And so if you look at, if we want to find the length of this arc, well, it's going to be 1/2 of the circumference. And actually, let me change that. Red's kind of an aggressive color sometimes. Let me change this. Circumference is pi times the diameter. So if they hand us the diameter, Q plus R is the diameter, they desperately want you to pick C. Right? So I see a lot of people running in, I think J.A., Des, a handful of people throwing in, they think it's D. Without telling me the math, why do you think it's D? Don't worry about the math, just tell me the logic. Why do you think it's D? Nice. This is a rule you should know, that if the diameter is the hypotenuse of a triangle that's inscribed in a circle, that's a right angle. So that's a right angle. So we actually have 3 right triangles within all of this. And there's a proof for it that actually I can go to the next slide. And let me do that. I'm going to run to the next slide so we'll have a little bit more space because we got rid of the answers. We can solve for this. And we can run through, I'll do the proof in a second. Really what I'm looking at is they made it too obvious that it's C. So I look at this one 2 ways, and hopefully you guys do too. If it's C, it's a stupid question. Who are they rewarding if they pick C? Right? If any 5th grader would look at it and go, it's C in 20 seconds, why is this the test that determines do you get into INSEAD or London Business School or Harvard or Stanford? Like, it's it's a bad test if this is a challenging question and the answer is C. So if you have limited time, this is where, and I hate to even say guess strategies because we can do better than guessing, but if you look at this and you're like, geez, this is one of those, to me, one of those, hey, I don't know if I can do it. I bet Stephen Hawking can do it because it's stupid if the answer is C. I may just guess D and go on. The other reason I ask that question is they give you the same amount of information. This one tells you one of the short sides, so statement 1 gives you this. Statement 2 gives you this. They give you the same amount of information. These two triangles basically serve the same purpose overall. If statement 1 is sufficient, so is 2. Hopefully you guys see that. They give you the same amount of information. You already have one piece of known information. It gives you a second side of a right triangle. They give you the same amount of information. So if one of them works, the other one does. This is one where I'd say it's 90% likely to be D and 10% likely to be C, just based on the structure. Now the other thing it tells you, because I don't want to stand here and just say, hey, let me show you how to guess a little bit more intelligently. You can do it. This also tells me this one is worth spending time on. I bet it's D if I'm a gambling man. Maybe it is C and they're trying to punish somebody who's guessing a little bit and thinks a little smarter than they really are. But at the very least, if I only have limited time on this test, there's a good chance it's D and not C, so I should put in some work. And if we want to look at what the work is, let's just do it because I'm going to work on statement 2. Just to show you guys, because it's a little longer of a side. If they tell us that this is 8, right, then what we know is that this long side YZ here, we know it'll be 4 squared plus 8 squared is YZ squared, which means YZ is going to be the square root of 80, right, 16 and 64. So we now know that. We also really have 3 triangles now. So in this bigger triangle, the big red triangle, we now have short side square root of 80 squared is this one, plus, if we call this A here, this side, A squared equals, and then it'd be this long side 8 plus Q squared. And we also have this one here where 4 squared, if we're using the small triangle, where 4 is the short side, 4 squared plus Q squared, just make sure this totally looks like a Q, equals A squared. And then you're realizing you have 2 equations, 2 variables. You could, and we could solve this. If anybody writes this down and finish it, you can totally attack from here. 2 equations, 2 variables. Even though they're squared, you'll actually see if you were to eliminate this, you can add A squared to this side, eliminate a variable. You can solve for it. So there's a proof where you can get it done. The real lesson I want you to get from it is they wanted you desperately to pick C. It's at least worth the time to check for D because there's just a dumb question if it is C. So you have that intuition that you need to go to work. This is an official question, by the way, so this is what they do. All right. Des. Brilliant question. On data sufficiency, you can't. Because this could be, they define Q as 2, it could be 2.1, could be 1.9. With data sufficiency, you can't eyeball it. Problem solving you can, unless they say not drawn to scale. Problem solving, if you kind of look at it and you're like, hey, that angle is definitely greater than 90 degrees, I'm only looking at that, you can do it. Data sufficiency, because you need an exact answer, you can't eyeball it at all. So good question. So again on this one, the answer is D, because they both give you, once you do the proof for one, you can carry it over for the other. But if you look at the stats on this one, people are pretty evenly split between C and D. All right, so if we throw this one up, this is a little bit smaller of a graph because I wanted to keep the diagram on it. They do trap a lot of people with C here, like we've seen in so many of these, so many of these cases. There's usually one common trap answer and one correct answer that around the same amount of people pick, and so kind of being aware, having that sixth sense of you about, hey, wait a second, they're making C pretty easy, I better investigate a little bit, is where you can make up a lot of ground. So even at that, Des, even at yeah, if you're using the scale, you can't, because it's just this could be intentionally manipulated. So problem solving, definitely. Data sufficiency, just as a general rule, only give what's explicitly given. The figure can lie a little bit, so be careful with that. So lesson again, if one answer seems a little bit too easy, then make sure you use that as an opportunity to investigate. Here, if we go back, it's pretty, actually, yeah, it's pretty obvious that it's at least C, that if you get the diameter, you have everything. So you want to try to leverage assets here. There's no way it's E. They're trying to make it C. So leverage assets. Can I get these statements to work on their own? Here's another one that's kind of an all-time favorite. I'm going to step back, see if I can get that poll cleared out for you guys. And if you guys want to take a look at this one, again, I'll give you about a minute. This is, like I said, absolutely an all-time favorite. So take a look and we'll discuss what you see. What I want to talk about after a minute or so is, what do they want you to pick, and what does that mean you're going to do? Cool. So take a second to look at it, and we'll be back to discuss. I'll give you another 10 seconds or so to finish up. What do they want you to pick here? For those who are done, who are thinking a little bit. All right. Maybe E, maybe C. And that's actually what our group is debating between, it looks like, A and C, or E and C. I don't want you guys to get the like intuition that C is always wrong. It's right 20% of the time. Here's the way I'd look at this one. Let me know if you guys, and I think I have this all up here, just so we have a little bit of space. If you look at, say we were to say that 52-cent size as a lemonade we'll call X, and 58-cent we'll call Y. As an equation, people see statement 1 tells us that X plus Y equals 9. And then for the second one, that 58's total value sold is 492. That means that 52 times the small ones, and actually let me just do it right underneath, we have plenty of space. 52 cents times the number of small ones plus 58 cents times the number of large ones equals 492. And I hate decimals, so I'll just keep everything in terms of integers. All right. So does everybody agree you can set that up just based off of what they gave you pretty quickly? All right, so let me know if anybody's against that. You could use L and S for large and small or something like that. X and Y work. All right. Thanks, Corey. So we have two equations, two variables. I don't see where anybody's getting E, to be honest. This one, maybe it's because you kind of have that intuition, okay, they're making C easy, right? Here, it's two equations and two variables. This is where that strategic idea comes into me. This one's a lot like one we did the other day with children on a school bus. What did we talk about when they said, oh, it was the number of children on a school bus? What did that mean for the numbers we were allowed to use? Yeah, these have to be integers, right? She's not selling 2/3 of a lemonade because they tell us she sold, there's two different sizes, that's all she can sell, right? So they have to be integers. Here's again where a little bit of data sufficiency intuition can really help you. If I'm saying, oh, it's two equations, two variables, it's C, then I'm leaving the integers thing on the table. This one basically tells me that they have to be integers, which means I have more information than just two equations and two variables. I have two equations, two variables, and I know two other things about it. That they have to be integers, and even if I were to divide this one out, which could work in some cases, if you divide everything by 2, then you have 26x plus 29y equals, and whatever that would be if you divide it by 2. I don't even necessarily want to, 246. What I want to get down to here is these are ugly numbers. It's not 2s and 4s or anything like that. You got a 29 and all that. There's probably only 1 or 2 combinations that will even get you to this. So based on everything I've just said so far, and if you've done any work, is it C? Where does your instinct tell you, even if you haven't done any more work on it? Can you really pick C and feel, yeah, not likely to be C? I agree with Linda. Which one do you think has a little bit more value to it? If you had to pick right now, if you had to guess, I don't think it's C. Which answer at least gives you a chance? Because if you pick C, you're not using the fact that it's integers, and you're not using the fact that these are pretty strange numbers. Right? So I, at this point, if I had to guess, would guess B. And again, I don't want to make it just pure guesswork strategy. This tells me two things. Man, I don't know that I can pick C. Again, dress for the job you want, not the job you have. C is a pretty easy answer to get. B might be hard to get, but man, it seems like they'd reward people for doing it. And there are a few ways to do it. If you want to use trial and error is a long way to go. This one, I'll show you the proof that it is indeed B. And actually, let me just show you the stats real quick. Whoops, I don't have it. This one's a lesson problem, so I don't have the stats. I would just be guessing at the stats, actually. Here's really the proof. And this one, bear with me on this one. If you don't totally get the proof, then I'll send you blog. I'll make sure PrepAdviser has a blog post. I'll put it in the forum in there that goes into this in more detail. But basically, does everybody agree? If I know these two things, I can solve it. Just give me these two facts and it's done. Two unique equations, two variables, it's over. So I can definitely solve it knowing these two. All right. So I think we're all on the same page there. Here's one kind of advanced technique you could use. If you know that you can do it with these two, but you don't want to pay for statement 1. You want it to be B because it's a more advanced answer choice. You can borrow statement 1 for a second and say, if x plus y is 9, I know that I get an answer. What if it could be 8 or it could be 10, right? Could it be anything other than 9? So I'm not using statement 1 with statement 2. I'm just saying if I do have it, I get it. So here's what I'd ask myself. Could it be 8? And could it be 10 with it being the total number of lemonades? I know, because I'm using statement 2, I know she made 492. So if I want to reduce the number of lemonades she sells and still make a full 492, which ones do I want to sell more of? And hopefully enough of you follow what I'm doing. I'm just trying to prove this is true without actually paying for the statement. I want it to be B, I just don't. But I know this is great information to have. Yeah, you're going to want to sell more of the big ones. And so, okay, could she, even if she sold all of the big ones, 8 58-cent lemonades, well, she still only makes, what's that, $4.64? Which means even if she sold 8 of the biggest ones she's allowed to, most expensive ones she's allowed to, she doesn't make enough money. So she cannot sell 8 because she would never make $4.92. And then same thing, if I wanted to increase it to 10, which ones would I want to sell more of? I know if she sells 9, she can make $4.92. What about 10? I'd have to sell the small ones. And so if we have 10 times the small ones, well, that's already too much. It's 520. So even if she sells 10 of the smallest ones possible, she can't make it. So statement 2 actually already tells me this. I already know this. So that's the proof for why it's B. It's a hard proof to go through, and again, this is basically an official question. I think we changed the name and the lemonades or whatever, but they've tested this a few times before, and what's interesting about it is the proof is hard and time consuming, but if you know that it's worth the time, hey, they wanted you to pick C, they made it obvious. 1, if you have the time, know to use the time to try to do something like this for a proof. 2, if you don't have the time, this is where data sufficiency, I think you have a better than 50-50 guess, even if you're down to 2 answers, because you kind of know, pick the answer that someone going to an elite business school would probably pick, not necessarily the answer if it seems obvious. If you're in between the two and like, man, they want me to pick C, B's in the hunt, I don't have time, I don't know, it could take me 5 minutes to prove it, you can at least look at it and say, I'm going to go with my gut on this one, and it's a stupid question if it's not B. So that's one more proof here. So the answer to that one is B. I should make sure we clarify that. And again, the takeaway, if it seems obvious, then run back to it. Here's one more that's similar theme, actually. Let's just talk about this one together. I'm going to hang back for a second, let everybody take a look. What I want you to think about is what do they want you to pick, and where does your instinct tell you to spend time? I don't want to really make it a guess. Where does your instinct tell you to spend a little bit of time? So that's what we're learning. These are, by the way, these are hard problems too. These are some of the more advanced ones we get. I just figure you guys are investing time in all this. I don't want to just go through a bunch of confidence builders. So if we have an hour and a half to talk data sufficiency, I want you to be exposed to the stuff that'll take you to the top. So talk to me here as you've had a chance to digest it. They tell us that line M is tangent to a circle, which is centered on 3, 4. Does it run through 6, 6? And statement 1 tells us it runs through 1 point. Statement 2 tells us it runs through another point, and that's actually the point where it's tangent. What do they want you to pick? Where are you leaning? So JA is leaning toward B. Other thoughts on this one? Ooh, B, obviously. Here's where I'm going to run back to. I think I mentioned this the other day, right? That poker quote from Rounders that if you can't spot the sucker at the table right away or in the first 10 minutes, you probably are the sucker. For those who are saying B, what do you think is the sucker choice? Oh, no apologies. Man, if you guys are saying B is too obvious, you guys are really good at geometry. Let me show you the stats on this one, actually, just so you can see. And this is where, again, my other goal isn't to make you paranoid, that if I think the answer is this, it's not. Don't think that way. Just think, okay, now I know what the game is. I know what they're trying to test me on. All right, so here are the stats on this one. It is B and a little bit more than half. Where they're really trying to get people on this one is with C. I should also mention this is one of our homework problems, so people do this right after they've come from the lesson where we're telling them to think strategically. So I actually think this one's a little bit inflated. I remember finding this problem in forums similar to PrepAdviser where people were beside themselves. Some of the real experts in that forum were like, how in the world does it be? So I like this one because what people like to do on this one is say, okay, I want to find line M. Well, okay, if I know that line M here, statement 1 tells me that it runs through -8, 6. Statement 2 says that it runs through 3, 6. Well, then I can connect that line. Actually, look, there's no slope and it just goes straight across. If I can draw the whole line, I can tell you if it goes through that point or not. All right. Now, if so, this is actually international crowds are always better at math. This one may play better in the States where, I don't know what stereotypes you guys have of American. I'm going to go to Walmart and drink a Mountain Dew on my way to eat something really fattening as soon as I'm done with this. So whatever your stereotypes of Americans are. We're also not particularly good at math. So this one, like, people are floored by this one in the States. But you guys are sharp. If I did that, if I said, okay, this one tells me this point, this one tells me this point, and now I can solve the entire slope, and I know the whole line, so it's C, what information am I not using? Yeah, I'm not using centered on this point. I'm not using tangent, and I'm not really using the circle at all. Right. So this is one of those leverage assets problems, so maybe better as a demonstration than as necessarily did you get it right or wrong. This one, like I said, it is tough. I've seen a lot of people miss it in all those kinds of things. If you pick C, you're leaving too much information on the table. This is another one where even if it seems obvious, and again, it's not that C is just, C makes for good demo problems because people like a couple information. We're going to do a couple more in just a second that'll be different variations on the theme. People like to pick C here, and that to me is, hey, wait a second, if the answer I picked doesn't use all the information here, I better go back. And so that's really what leverage assets is all about, is if you drew this diagram and there's not a circle in it anywhere, you better go back and determine that. Here what they're saying is that if it's tangent to the circle here and the circle is centered on point 3,4, it's not necessarily circle, let's make the center big, well then we know that it's going to be perpendicular to the diameter there. This one's interesting. Actually, when I first saw this problem, I didn't know this rule that these two are perpendicular. What I did know, this is maybe a demo for me, is that I knew everybody was picking C, and I wanted to say, well, if you don't do it, it's a weird question if it's not B. The reason that you can use it with B is there is a rule that at the point of tangency, the diameter is perpendicular to the tangent line. Or the other thing you can do is, hey, I don't know if there's a rule, but let me just draw a tangent line to a circle, which is kind of terrible there. Let me find a better one. And it turns out, even if all you did was kind of on your scratch pad, like, okay, this is tangent here. Can I draw another line? No, that'll cut through it. No, that'll cut through it. There's only one line you can draw there. If you add a protractor or something, you could totally make it work. So this is one of, to me, this is the, hey, even if I don't know the rule, there's got to be a rule because there's only one line you can draw if it touches exactly one point. If my instincts tell me it's C and it's kind of obvious, but I'm leaving information on the table, I better consider how would someone who gets a higher score than me use this information. If I think there's a way to do it, either I invest the time in trying to prove it, or I just, even guess B in this case. So the answer is B. And what I really want you to get from it is if your answer leaves entire statements, entire algebraic equations or definitions or anything on the table, doesn't necessarily mean you're wrong, but it means you probably need to do a little bit of thinking. Like, go back and reconsider that. Cool. So questions, comments? Thanks, I may have missed you. Apologize if people have any kind of connection trouble. It seems like it's working pretty well for most people, but we're recording this too. All right, where are we at? Okay. Couple more minutes. I want to show you one more strategic, insight. take a look at this problem. I'm going to clear out the poll, give everybody a fresh look at this one. Take about a minute because it's pretty conceptual with statistical terms and everything. I'm going to clear the poll, take a minute. There's one more element of strategy. What we've done so far is just kind of using the structure. If it feels too obvious here, see, is there information I'm not using? Try to leverage those assets. It's been really one of the biggest things we've done. This one, there's one other way to really use the structure to your advantage. So attack this one in a minute. I'm going to clear out the poll, and then we'll come back and add at least one more real, tangible strategic insight. And I'll let you guys work out. I see people typing some of those in. The poll is open too if you guys want to attack that. So let me duck over. I've got some C's, some A's. Cool. Let's discuss. Okay, and JA, I like what you're saying here. Here's just a little bit of insight into a strategy that people don't realize you can use, I guess. So if people look at statement 1 alone, and just say, okay, A is the median of set J. What does the median mean? So our group right now is relatively well split between A and C. Just so you guys should have published that, but we're this is where we're at. What does median mean? Yeah, it's the middle number, middle segment, perfect. So if you look at this one and say, okay, well, if it's the middle number, it's going to go right in between 7 and 12. So it'll be 2, 7, A, 12, and 17. All right. So if you look at this and say, yeah, it's between 7 and 12, and then pick A, sorry, say statement 1 sufficient. I actually, okay, and median's a good point, Jim. Median's the middle number. Mean is the average. So, some of the content stuff is, it just takes, sometimes you just have to make a mistake to get there. So, and Rosie actually had a huge point. It's the middle number in an odd numbered set. If it's even, it's the average of a 2 number. So, Jim, you actually were half right on that too. If you look at this and say, yeah, it's between 7 and 12, so it's bigger than 7 and it's less than 12, I forgive you. I think that's a pretty common mistake to make. However, and actually let me show you that it's a common mistake to make. People pick A all the time. But let's go back. They do give you a clue. Does anyone think statement 2 alone is sufficient? What is A greater than 7, set J doesn't have a mode? Well, that just means there's no repeat number. But, man, A could be anything. Could be negative a million, could be positive a trillion. I don't know. Statement 2 is so worthless on its own, there's only one reason it's there. And it's either a clue that, hey, if you didn't consider repeat numbers, you better go back and reconsider. You either need it or you don't, but we want you to ask, why are you here? Meaning, if one statement is worthless, it's either totally sufficient and no one in their right mind would ever say it's not, or it's totally insufficient and nobody would ever say that it is sufficient. Like, no, A could still be absolutely anything here except for 2, 7, 12, and 17. No one's ever saying this is sufficient unless they're rushing or guessed or just got dropped in from outer space or came in a little bit tipsy, whatever. There's no way anybody in their right mind is picking B. So why is it here? You can use it as a clue. And this is where a lot of times people get blinders. They make their decision on statement 1, never look at it again. Then look at statement 2 and make their decision with blinders on, and then only look at them together if neither is sufficient alone. What you want to do is, if statement 2 introduces information that you didn't think about in statement 1, and especially if it's totally worthless on its own, you want to consider, hey, wait a second, this one tells me that I can't repeat numbers. Did I consider that maybe I could repeat numbers? And if this set were 2, 7, 7, 12, and 17, this is still the middle number. So here it could be 7, it's not obvious. When they put it in here and tell you, hey, what about repeat numbers? You better use this as a clue. So the answer is C, but people go for A a lot because they're not really, their eyes aren't open to, hey, that just added new information that may be interesting. Did I know that before? Did I not? Would that be important? Would it not? It at least tells you, you better consider repeat numbers. Cool. So be aware, like that flexible thinking is so important. Even if you've made your decision, yeah, that's totally sufficient. If statement 2 says, hey, did you consider negatives or non-integers or repeat numbers or something else, let that at least be a clue that you can go back and reconsider. So you're allowed to change your mind. And especially if a statement's worthless, ask yourself, hey, why is that even here? I love doing this presentation when we're working with anything where we work with the people who write the test. Because I always like to ask them, I'm like, hey, when you write a data sufficiency question, how many people write it? I'm like, well, 1. I'm like, okay, so it isn't one person asks a question and then 2 individual people write down a statement. Here, whoever wrote this question wrote this statement for a reason. If they know nobody's going to pick it, it's either there as a clue or as a trap, but it means you better figure out why it's there. Cool. So let me pause on that. It's a pretty big strategic point. We'll hit one more with it and then wrap up. Does everybody see what I'm getting at there? If one statement is totally obvious, the only real logical reason it's there, it's either a clue or a trap. So nice, perfect. Yeah, it's actually, I need to reconsider. I need to make sure we vary the right answer choice on these. So yeah, it's not that C is always wrong. It just makes for really good demonstrations when they're wrong. So here, if one statement's obvious, it's there either as a clue or as a trap, but it tells you I need to invest some time in figuring out why it's there. And so we'll do one more that's an example of that. Here's a question. This one, the stats are actually really pronounced on. Why don't you guys I'm going to clear out the poll, take a full minute or so, a minute and a half on this one. I know we're running up toward the end of the session we have here, so we'll finish this one and then totally wrap up. I'll clear that poll and be back in a minute or so to discuss. So how's everybody doing here? I think our stats are open. We're pretty evenly split between A, C, and E, which I love because what does that tell you? Is anybody thinking that statement 2 adds any value? What is Z? Y is not prime. Statement 2 is utterly worthless on its own, which makes it a great demo for hey, we may need to consider that. So talk to me about statement 1. This one takes a little time to totally unpack, I think. Z is the remainder, so they're defining it when positive integer y is divided by positive integer y minus 1. How did you guys attack that? A lot of ones. I think one gets in there. Okay. The way Des just kind of explained the entire thing. Perfect. Thank you. I think a lot of people will pick numbers. It looks like that's what a lot of the responses coming in are. We've got some algebra, which I've actually never totally done it the algebraic way. So let me just show you where I think this is the best demonstration of how to kind of use the structure and not just the question. I think a lot of people will start and say, okay, y, positive y, y minus 1. Let me just pick some numbers. If this is 5, then y minus 1 is 4. And so, okay, well, that's just going to be 1, remainder 1. All right, so, okay, I get what that looks like. Let me try again. Okay, what if it's 10 divided by 9? So y, and then y minus 1 would be 9. Okay, that's 1, remainder 1. Okay, what about, say, try something crazy like 101 divided by 100. Okay, it's still 1, remainder 1. So yeah, it looks like it's always going to end up where you have 2 adjacent integers. When you divide one by the other, then, okay, you're going to end up with just that difference is always 1. All right. Everybody follow that? Again, if you pick A here, or say statement 1 is sufficient, I'm not mad. I think this is, you pick some numbers and played with it. There's 2 things that you really do need to be aware of, though. 2 ways to avoid falling for this trap answer. All right, so out of a little over 1,000 people, 650 on this one have picked A. People like A. And it's because they aren't aware of 2 big things that can help you. If statement 2 says y is not a prime number, all right, what are the unique prime numbers? If I say prime number, what comes to your mind? What's the smallest prime number? What's the only even prime number? Yeah, 2 is the smallest prime number because it has to have 2 factors and it's itself and 1, so 2 and 1. 1's actually not considered prime because it only has 1 factor. 2 is the only even prime number. So if you pick statement 1 is sufficient, oh, it's always going to be a remainder of 1. Okay, that's not bad. When you get here and they go, y is not a prime number, a lot of people look at this and go, freebie. I don't even need to consider it. No one's ever going to pick this. Okay, it's A, easy. A more astute test taker looks at this and says, hey, wait a second. Did I even consider prime numbers to start with y? What prime number should I think of? Okay, what if it was y equals 2 and y minus 1 equals 1? Well, 2 divided by 1 is just 2 with no remainder. And so that could be 0. So that's 2, remainder 0. There is my devil's advocate. So if you're picking numbers, remember we said if you pick numbers, play devil's advocate. Usually play devil's advocate. I would say there's 2 ways to save yourself from that trap answer here. One is, hey, what are they going for here? What prime numbers might give me something different? Because I wonder if I need this. Go that way. The other one is when they say positive integer y divided by positive integer y minus 1, y minus 1 is the smaller one. Smallest positive integer is 1, so that tells you it'd be 1 and 2. I think a couple people put that in here. Data sufficiency plays to the fringes. If you always pick numbers that are in the middle of the range, you'll usually get the same answer. But if you pick the smallest you're allowed to, the biggest you're allowed to, then you can start to break it a little bit. So really there's 2 ways to save yourself from that big trap. One is, hey, they said it's not a prime number. What this does is say, okay, you can't use this one. Since 2 is prime, this one doesn't count, which means it guarantees if you use both of these together, it's always 1. So the answer is C. Even more importantly, if one of these statements is worthless, there's a reason it's there. You better ask yourself. Sometimes it's a trap. Sometimes you don't need it. Other times you do, but it means I better consider what kind of prime numbers might be a little bit different. So that statement helps you play devil's advocate a little bit more. The other thing to know is if you're picking numbers, always try as low as you're allowed to go, as high as you're allowed to go. If they say X is greater than 10, don't just start with 11. Try 10.000001. It's like, what if I bumped it up a hair? See how that works. So they play to the fringes, try the lower limit and upper limit, and usually that'll help you work through it. Cool. So that's that strategy of why are you here. I think we have that kind of labeled up here with this. This one, again, C can be correct. A lot of times when it's this kind of a structure, when one statement looks like it's sufficient, the other one gives you a clue of, but did you think about this exception? And so be aware of all that. As we wrap up for now, again, this one I'll just kind of leave so it gets on the recording. Think about these a little bit structurally, that it's not just about do the math and see what you get. A lot of times it's, hey, they want me to pick C, let me consider something else. Hey, they're making it pretty obvious that it's A and statement 2 is worthless, I better check for C. And this way of thinking about it can help you think kind of problem solving strategically, really managing your assets well. And so, again, I wanted to make sure these links stay up for people for just a little bit. In order to get tomorrow's video lesson and to get the practice tests on Friday, people were asking about that. Run over here and you'll be able to get all the resources. So tomorrow's the video sentence correction lesson. I'll see you via video that way. Friday is the practice test. That'll open up here on Friday. And then next week, come through here. Week from today, same time, similar place. We'll do a Q&A session and kind of cover everything. If you have questions in the meantime, use this forum here. And thanks again, everybody, for all the participation and questions and things. I think they may shut down the studio to start generating the recording for you guys, but I'll hang on for a second on chat. And look forward to seeing you guys, I guess, virtually tomorrow and in person again on Wednesday. Thank you.